All right, let's take a look at Unit 6, Lesson 19, Beyond Circles. This is the last lesson of our trig unit. 19.1, Notice and Wonder, Examining Data. So here's some data that we're going to study in today's lesson. So what do you notice and what do you wonder about these three, or the data? It's not really three separate tables, it's just continuing data. That's broken up into three tables because they didn't have enough room. So look at the data and see what you notice and see what you wonder. Some of the things that I notice are our days go from 1 to 31, but our amounts are anywhere between 0 and 1. They don't go below 0, so we have no negatives, and none of them go above 1. The numbers appear to increase very briefly, but then they start decreasing, and they continue to decrease until we get down to 0, and then they come back up. They also are not, it's not a parabola, it's not quadratic, because while 16 and 18 are the same distance away from 17, 15 and 19 are not. So it's not quite quadratic, although it could be. No, it couldn't, because it goes down, it goes up and then down, 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 back up, 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 right? So most of them, they tend to be, except for like this group, once you get here, it looks like it's about 0.10, 0.10, 1/10 every day for a pretty consistent number of days. So I wonder, like, what do they represent? We know that the first column is days, but amount of what? And then, why do the numbers change? Like, they're not the same numbers when you decrease as when you increase. Why are those numbers different? Why is it not a constant rate? Is this for one particular month? Because it says 31 days, so it could be a specific month. Or it could just be 31 days. Who knows? All right, so let's take a look at 19.2, watching the evening sky. So we have data from the warm-up, and that is the amount of the moon that is visible from a particular location on Earth at midnight for each day in January of 2018. A value of 1 represents a full moon in which all of the illuminated portion of the moon's face is visible. A value of 0.25 means that 1/4 of the illuminated portion of the moon's face is visible. All right, so what is an appropriate midline for modeling the moon data? What about amplitude? So remember that we went from 0 to 1. It went from 0 to 1. So your midline would be at y equals 0.5. Right? So the amplitude is 0.5. All right. What is an appropriate period for modeling the moon data? So looking at a period, remember when we were looking at the graphs, we looked from one maximum to the next maximum. So on day 2, it was at a maximum, and then it drops down, hits the minimum. So here's the max, here's a minimum, and then it comes back up to the maximum there. So the difference between the two maximums, 31 minus 2 is 29. All right, so 31, so max at 31 and, well, here, let's do this. Max at day 2 and day 31. So 31 minus 2 is 29 days. So the period would be 29 days. All right, number 3, choose a sine or cosine function to model the data. What is the horizontal translation of your choice of function? So I'm going to use cosine since we're starting at a maximum. And then if we come back up here, day 1, which is our starting date, isn't the maximum. Day 2 is. So we've actually shifted 1 unit to the right so that we can start our maximum at 2. All right, so we're going to shift 1 unit to the right. So our horizontal translation, we'll put so. Horizontal translation. Remember, when we go to the right, it's negative, so -1. All right, propose a function to model the moon data. So we have f of d for days equals, remember our amplitude was 0.5. We just determined that in part 1. We are looking at a cosine. And, oh wait, that's not where I want my parenthesis. I want it to be after cosine. Our period, remember that our normal period is 2 pi, but we are looking at 29 days, so it's 2 pi divided by 29. And then we shifted 1 unit to the right. And then our vertical shift is at 0.5, so we're adding 0.5 there. So remember that this 0.5 came from our midline, and then this 0.5 came from our amplitude. They just happen to be the same number. So keep that in mind. All right, I'll get rid of that. Oh, wasn't trying to get rid of that part though. There we go. All right, so we also need to specify the units for our input and output. So where D is the number that looks like this. Let's fix that. D is the number of days since January 1st. What was it, 2018? Yeah, 2018. 2018. And then F is the amount of the moon, or F of D, is the amount of the moon that is visible. As a decimal between 0 and 1. All right, so then we're going to plot the data using graphing technology and check our choice of parameters. All right, so let's take a look at our graphing calculator. All right, so 1, 2, 3, 4, no, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and 31. Okay, so now let's come back up here. 0.99. And be careful as you're typing these in. It's very easy to make a mistake. And so I actually made a mistake the first time I was doing this, but I didn't want you to have to sit through all of my fixing of my mistake. So I just started over, but it's very easy to make a mistake. So check as you're going to make sure that you're typing in the data correctly so that you get the right output. Okay. And this is why whenever people are collecting data like this, they always have people checking to make sure it was entered in correctly, because that can be quite a challenge. And it can mess up your inferences and different things when you're analyzing the data. So you have to be careful when you're entering in data. And there we go. Oh, that's one. Okay. All right, so now we have our graph. And so let's go back up to here. Plot the data, check your choice of parameters. And we're also going to plug in our model. So we had y equals 0.5 cosine of 2 pi divided by 29, and then parenthesis x minus 1, and then we're going to come outside the parentheses and add our 0.5. All right, so there is our equation, and we need to make sure we are in radians, which we are, and that looks good. Okay. And so let's look at our model. So here's our model, and there are our data points. And so something doesn't look right here. So let's go back and look. 2 pi over 29, x minus 1. Oh, that's 0.5. That should be 0.5. Ah, that's so much better. Okay, I was going to say our graph did not look very good. But there you can see, let's fix that. We'll go from 0 to, 32. And we'll go from 0 to 1 here. Ah, that's a little bit better. All right, so there you go. We can see it's a fairly good model. We might want to shift it a little bit more to the right. It's pretty much it's a pretty good fit. So if we were to leave it the way it is, if we wanted to change the period maybe to 30, let's change that period to 30. That fits a little bit better, right? So we'll change the period to 30. All right, then we're gonna use this to predict the next 2 full moons. So we had the one on day 2 and then the one on day 31. So this one is at day 61, and then day 91, right? So those are the new predictions. And so 61 days after January 1st, 2018 was not a leap year too. So, all right, so January 2nd to the 31st would be 29 days. Plus February had 28 days. So that's 57. So we need 4 more days. So that'd be March 4th. And then 30 days after that, 31 days would give us April 4th. That'd be 31 days. And then another, oh no, we only want 30 days, right? So It would be, not February, why do I keep doing February? It would be April. April 3rd. So how much of the moon do you expect to be visible on your birthday? So you find your birthday. All right, and there is your summary.